Greetings of the day. I'm Dr. DJ Ashpin, Pabi, Assistant Professor, Department of Computer Science and Engineering, Madanapalli Institute of Technology and Science. So today's lecture, we are going to see some of the pseudocodes and we'll try to trace the output for the pseudocodes. So first one is, what will be the output of the following pseudocode? So in the following pseudocode, x, y and z variables are initialized. So three variables, x, y and z, and the value y is stored in y, 1 is stored in y and 2 is stored in x. And we have to perform XOR between x and y, and that is our z, and we have to print the output of the z. So first for this you should know how XOR can be performed between x and y values. So the values of x and y are x is 2 and y is 1. So the value of x equal to 2 and y is equal to 1. So we need to perform XOR between x and y, and that is our z. So for XOR, to perform XOR, this is a bitwise operator. So what your XOR will do is, first the value of x, that is 2, will be converted into bits. So the value of x is 0, 0, 1, 0. And y is 1, it is nothing but 0, 0, 0, 1. And we will be performing XOR. So what will happen is, if the two outputs are same, that is x is 0 and y is 0, means the output will be 0. And if x is 1 and y is 1, means the output will be 0. Otherwise, the output will be 1. So for this case, this one, 0 and 1, we need to take XOR. 0 and 1. So XOR between 0 and 1 is different. So the output will be 1. The output will be 1. And the next two digits, when you take XOR between 1 and 0, it is different, right? Two inputs are, see, 1 and 0, it is different. So if the inputs of x and y are same, then only it gives the value 0. Otherwise, the value will be 1. So here it prints 1. And then 0, 0, of course, 0, same input. And then 0, 0, 0. So you'll get the output as 0, 0, 1, 0. When you convert this 0, 0, 1, 0 into decimal, the decimal value of 0, 0, 1, 0 is 3. That is our z value. That is our z. So you'll get the output as 3 for this particular pseudocode. You'll get the output as 3. And the next pseudocode is this one. So here, 3 variables a, b and c are used. 3 variables a, b and c are used. A, b and c. And the value of b is 4 and the value of c is 5. So what will happen means, next for loop is used here for each a from 0, 2 to 4, which means how many iteration is, iteration started from 2 and it ends at 4. So 2, 3, 4, 3 iterations will happen here. So you'll get the output in 3 numbers, right? And then print c. So it will print the value of c, and b is b minus 1 and c is c plus b. So now let us try to trace the output of this. So initially what will happen is, so the value of b is 4 and value of c is 5. So at the first iteration, when a is equal to 2, it will print the value of c. So initially it will print the value of c. So 5 will be, the value of c is 5 here, so 5 will be printed. And then next one, what will happen at the first iteration when a is equal to 2, I'm speaking. So b becomes b minus 1. This time b becomes 3. 4 minus 1, 3. And c becomes c plus b. So the value of c is 5. So 5 plus 3 is 8. And next, the loop will be continued, and now a becomes 3 and it will print the value of c. See, the value of c from the previous iteration we know that we got is 8. So 8 will be printed as the output. And again b becomes b minus 1. In the previous iteration we decremented b by 1. So now b becomes 2. So previously it was 3 and 3 minus 1 is 2. And then c becomes that 2 plus c. The value of c value previously is 8. So 8 plus 2, 10. So 10. Right? And then what will happen? The value of a becomes 4 and it will print the value of c. So the value of c is 10. Anyhow, the loop will be continued, which means b becomes b minus 1 and c becomes c plus b. But the loop will be terminated because here inside the for loop, you see, we started the loop from 2 and we have terminated at 4. So what will happen? The loop will be terminated and we get the output 5, 8, 10. So the option A will be the output for this particular pseudo code. And the next one is, so integer value n is defined and the value 1 is assigned to the variable value and the value 45 is assigned to the variable n. So while value is less than equals to n, we are performing left shift to 1. So this this cursor, okay, this is nothing but this operator is nothing but left shift, which means what will happen? The bits will be, so first what will happen? The value will be converted into, so this is a bitwise operator, So what will happen? It will move the bits by the number of steps you assigned here to the left. It will move the bits to the left. Towards left, the bits will be moved, right? By the number of steps you have assigned. So here, how many number of steps we have assigned? Only 1, which means one time the bits will be moved towards the left side. So automatically when you move the bits towards the left side, what will happen? The value will be increased. And when it will be terminated? It will be terminated when the value less than equals to n, which means when the value of value becomes 45 or less than 45. It will be terminated. So initially in iteration, what will happen? So it starts from 1. So of course, inside a while loop, it will check the condition whether this value 1 is less than or equal to n. So the value of n is 45 and the value of value is 1. So of course, 1 is less than or equal to 45. So what will happen? One time, the bit will be moved to the left side. So when it moves, what will happen? We'll get the value. Right? And similarly next time, so that particular value will be assigned to this value and again it will check the condition whether this value of value is less than or equal to n, right? N is 45. So like that, you see, the loop will be continued until the value of value becomes less than or equal to n. So let us see what will be the output, right? Which means what value you will get at the end of the loop. So we will see here, what we have here is, we have the value 1 and then n is 45. So until the value of value is less than or equal to 45, the loop will be continued. So what will be continued? Value is equal to value left shift 1. So the value of value is 1 and its binary form is 0, 0, 0, 0, 0, 1. So to move so first iteration, So we know that the value of value is 1, which is less than 45, which is less than 45. So the condition is satisfied. So condition satisfied means body of the while loop will be executed. Inside a while loop, we have value equal to value left shift 1. So now what will happen? This bit will move here, and the next bit move here, and the next bit will move here, right? So automatically what will happen in this place, it becomes empty. So empty you need to fill with the 0. So when you do that, what you get here is, you'll get like, so what will happen? This will move here. So 0 comes here, and this 0. Right, will be removed. So 1 is moved here. 1 is moved to this. That 0 is moved here. That 0 is moved here, like that. And this become empty. We have filled with the 0. So now when you convert this 0, 0, 1, 0 to the decimal, what you get is, you will get 2. You will get the value 2. How we get is, I think you all know how to convert this binary to the decimal value. So 0 into 2 power 0. So of course 0 into 2 power 0 is 0. Alright. And then 1 into 2 power 1 is 2. So you'll get the output as 2 after this iteration. Right. So next iteration. Again what will happen? The loop will be continued. So now the value of value is 2. It will check the condition. The value of value is 2, which is less than or equal to 45. So what will happen? The statement now will be executed. So now value becomes value. Again, one more time left shift 1. So I told you already, like left shift, when you are doing, the value will be increased. So previously we got this output. So from this, what will happen? The bits will move to the left side. So you will get like 0, 0, 1, 0, 0. Right? So 0, 1, 0, 0, which is equal to the decimal value 8, which means 0 into 2 power 0 is 0, and 0 into 2 power 1 is, because coefficient is 0. So when you multiply any number with 0, you will get the output as 0. And here 1 into 2 cube. So what is 1 into 2 cube? It's of course 8. So 8 decimal value you will get. And again the loop will be continued. Why? Because no, 8 is less than or equal to 45. 8 is less than or equal to 45. Here we have the value less than or equal to 45. So next the loop will be continued, and again one more left shift by the position 1. So now what will happen? This 0, the bit 0 will move to here, and this 0 will move to here, and this 1 will move to here. So you'll get the output as 1, 0, 0, 0. And this is equivalent to 2 power 4. That is 0 into 2 power 0, 0 into 2 power 1, 0 into 2 power 3, and 1 into 2 power 4. 2 power 4 is 16. So you'll get the output as 16. And it will check the condition. For the next loop, the loop will be continued. It will check the condition, which is less than or equal to 45. So now what will happen? Again the loop will be continued, which means it will be left shifted by 1 position. And now when you do that, again what will happen? The value will be increased, and then you will get the output as, so if you do like this, next iteration you will get the output as 32. So 32, of course, it is less than or equal to 45. It is less than 45, right? So the condition is satisfied. Right, it is less than 45, so condition is satisfied. So what will happen? The body of the while loop will be executed. So while you have value is equal to value left shift by 1. So again it will be continued. Again it will be repeated. So now again when you do next time one time shift, again what you get is 64 you will get. Again 64 you will get. So 64, of course, again the loop will be continued, and it will check the condition. So 64 is greater than 45, so the condition fails. So when the condition fails, what will happen? The loop will be terminated. The loop will be terminated and then it start printing the value of value. So now the value of value is 64. So you'll get the output as 64. So once again I'll tell you. So when you do left shift for one time, what will happen? First it will convert the given input into given input, that is the value of 1, which means 1 will be converted to the binary, and then the most significant bit will be, right, all the bits will be one time it will be moved towards the left. So one time when you are moving, automatically value will be increased. So that is the reason you are getting the output as 64. Okay. And we will see the next pseudocode. Yes. So in the next pseudocode, you see two variables x and y are used here. X and y, two variables x and y are used here, and the value of x is 15 and the value of y is 12. And y, you see, we are reducing x, okay, 1 from x, and that is y value. So which means initially this y becomes x minus 1. What is x minus 1? The value of x is 15. So 15 minus 1 is 14. So y becomes 14. And then do. So you should know how this do while will execute. So I'll explain you how do while will execute. So do. So the statement inside the do loop will be executed, and then condition will be checked. So if the condition is satisfied, then again the control will come here and do statements will be executed. So when the statement becomes failed, when the condition is not satisfied, that time the do while loop will be end. So how do while loop will execute? First, the statement within the do loop will be executed at least one time before checking the condition. First, it will execute the statements, then it will check the condition. So if the condition is satisfied, then again the statement will be repeatedly executed. Right. When it becomes fails, the loop will be end. So like that only do while will while will work. But while loop, if you are using, it is different. While, how it will work now? First it will check the condition. If the condition is satisfied, like previous, if you move to the previous pseudocode, you can find. So how while is executing here? While it will check the condition. If the condition is satisfied, then only value equal to value left shift 1 will execute at least once. But here do while is different. At least once the statements will be executed, then the condition will be checked. And then if the condition is satisfied, the process will be repeated. Otherwise, the loop will be terminated. So here do while is used. Okay, now let us trace the output for this particular pseudocode. So now y is equal to x minus 1. The value of x is 15. So it becomes 15 minus 1, 14. And now it will print the value of x. So the value of x is 15. So 15 will be printed. And then x becomes y plus. So what is the value of y? Y we changed here, right? Y becomes x minus 1. That is 15 minus 1. Initially 12 was assigned, but in the next step the value of y is changed. How it is changed? It is changed to x minus 1. So now the value of y is 14 only. Value of y is 14. So 14 plus, what is x minus 2? What is the value of x? The value of x is not changed, right? So 15 minus 2. So what is 15 minus 2? It is 13. So the value of x becomes 27 here in the first iteration. 27. Then what will happen? The control will move to the while loop and it will check the condition. So the value of x here we got is 27. It will check the condition whether this 27 is less than 40. Of course, we know that 27 is less than 40. So condition satisfied. I told you before, like if the condition is satisfied, the statement of do will be executed. So again, the control will come here and it will print the value of x. So now it will print the value of x as value of x from the previous iteration is 27. So 27 will be printed here. And again now x becomes y plus x minus 2. So the value of x is y. So what is the value of y previously? Value of y is 14. From here 14. And now plus x minus 2. From in the previous iteration we got x value as 27. So 27 minus 2 is 25. So 14 plus 25 is 5, 4, 9 and 39, right? So now the value of X becomes 39. And now again the control will come here and it will check the condition. The condition is X is less than 40. The value of X is 39. So 39 less than 40. Of course 39 is less than 40. So what will happen? The loop will be continued. So control move here. And now it will print the value of X. So what is the value of X? The value of X is 39. So 39 is printed, will be printed. And again X becomes Y plus X minus 2. Right? X becomes Y plus X minus 2. So X equal to the value of Y is 14 plus what is X value from the previous iteration? It is printed at 39. So 39 minus 2 is 37. So what is 14 plus 37? It is 51. So the value of X became 51 and it comes here and it will check the condition. The condition is X is less than 40. So the value of X is 51. Whether 51 is less than 40? No, 51 is greater than 40. So the condition fails here. So since the condition is failed, the loop will be terminated. So what output we get? We got the output as 15. So first time initially value of X is 15. It is printing and then only it is changing the value of X. So 15 will be printed and next time 27 and 39. So you'll get the output as 15, 27, 39. Like this you have to trace the output. So for this you should know how this do while loop will be executed. Then only it is possible, to trace the output for this case. Previous case, it is less than. How the binary operators will work once if you understand it, it will be easy for you to trace the output. And the next one. Right. So next one is here, what we are doing is, we are taking your pseudocode contains, you see, 3 inputs, A, B and C. A, B and C. And the value of B is 0 and the value of C is 0. Okay, so B and C holds the value 0 and the A we are using for iteration purposes. So how many iterations? A from 1 to 5, which means 5 times, no? 5 times it will be iterated. Okay, the body of the for loop will be iterated, which means repeatedly it will be executed 5 times. First, initially A becomes 1. A becomes 1. So total 5 iterations, okay? A becomes 1 and it will print C. So the value of C initially it is 0. So 0 will be printed. And B we are increasing by 1. So what is the value of B previously? 0. Now it becomes 1. So B becomes 1 in the first iteration. And then C is C plus B. What is the value of C? Of course, initially it is 0 and the value of B from the previous step is 1. So now 1 plus 0, it becomes 1. So the value of B becomes 1 and C becomes 1 in the first iteration. Okay, in the first iteration, we'll write here. So value of B becomes 1. It's small b becomes 1 and C becomes 1. First iteration. Second iteration, because A already we have seen, A is from 1 to 5, right? 5 iterations. So first iteration is this, right? So next in the second iteration, right? Second iteration again, print C, it will print the value of C. So from the previous iteration, the value of C is 1. So 1 will be printed. So previously 0, 1. 0 and 1 we got. And now you see B, we are increasing by 1. So B is equal to B plus 1. So what is the value of B from the previous iteration? It is 1. Right. So now 1 plus 1, B becomes 2 now. B becomes 2. And then C is equal to C plus B. From the previous iteration, the value of C is 1. And from the previous step, the value of B is 2. So now C becomes 3. C becomes 3. Right. And again, what will happen? The loop will be continued for the third iteration. Right. The loop will be continued for the third iteration and it will print the value of C. So from the previous step, we got the value of C as 3. So 3 will be printed. 3 will be printed, and the value of B is 2. Okay, you have to track this. Okay, C is equal to 3. And now what we perform, B becomes B plus 1. The value of B is 2. So 2 plus 1, it becomes 3. So B becomes 3. And then C becomes C becomes C plus B. So what is the value of C from the previous iteration? 3. And from the previous step, the value of B is 3. So 3 plus 3, C becomes 6 now. C becomes 6 now. And now the loop will be continued, and you will move to the fourth iteration. You will move to the fourth iteration, right? So A up to 5 you can have. 5 times 5 iterations, no, you will get. And now it will print the value of C. So what is the value of C? 6. So 6 will be printed. 6 will be printed. So we got from the first iteration, the value of C only we are printing. First C 0. So 1, 3, 6. Okay, 0, 1, 3, 6. And next is the fourth iteration. Okay. So fourth iteration, what will happen? B becomes B plus 1. So again, one more time it will be repeated. So you'll get the output like 0, 1, 3, 6 and 10. Right? This is how you need to trace the output when you are having for loop. So A from A to 5. That is the reason you see 5 iterations. Okay. At the fifth iteration, condition will be right. Next iteration condition will be failed, and it doesn't comes here. It doesn't comes here. Okay. So the last iteration, fifth iteration value will not be printed. Because it becomes A becomes 6. When A becomes 6, then only fifth iteration C value can be printed. So fifth iteration C value cannot be printed. That's why you see 0, 1, 3, 6 and 10 is printed as the output. Right. And next, previously we have performed left shift, and here you see in this particular code we are going to perform the right shift. So already I told you that when you are doing left shift, what will happen? The values will be increased, but when we are doing the right shift, the value will be decreased. Of course. So what we do is just we convert this 32 into binary. So 32 into binary, and then we will be performing the right shift. So first you should know the binary value of the 32. So the binary value of the 32 is 1 0 0 0 0 0 0 0 and 3 0. So total 5 zeros. So this is the binary value of the 32. That is 0 into 2 power 0, it becomes 0. So 0 into 2 power 1 becomes 0. 0 into 2 power 2, it becomes 0. 0 into 2 power 3, 8, 16, 32, right? 1 into 2 power comes. So you'll get 32. So this is the binary value of the decimal 32. And now what we are going to do is we have to perform right shift until the value is greater than equals to n. The value of n is 1. So what is the value of n? Value of n is 1. So until n greater than or equal to 1. Until the value of n greater than or equal to, until the value of value greater than or equal to n, we need to perform right shift by 1 times. So now initially what is the value of value? The value of value is 32. Of course 32 is greater than n. N is 1. 32 is greater than 1. So you can do right shift by 1 times. So when you're performing right shift, you see, if you do this, it will be easy for you. What you have to do is you have to keep a decimal point. Left shift means, of course. So what you do, you will move for a left shift. What you do for 1 times, you just move this bit to the left, then this bit to next, this bit to next, this bit to next, this bit to next. So you'll get a space here. That space you are filling with 0 and the value is getting decreased. But here not like that. What you do is you just move, you have to move this particular bit to the right side. But we don't have anything at the right side. So what you can do is we can add some zeros at the right. So how this logic will work now? Of course, what is the difference between 10 and 10.0? Can you tell the difference between 10 and 10.0? So 10 and 10. We know that 10 and 10.0 is nothing but 10 only. So here we are not changing the value. We are just, for understanding purpose, we are just adding a decimal point. That's it. So one decimal point is added, and now we are going to do the right shift by 1 times. So when you do the right shift by 1 times, what will happen? This 0 comes here. And then this 0 goes here. This 0 goes here. And this 0 comes here. This 0 comes here. And this 1 comes here. So automatically you see this 1 comes here. Right? Automatically you see the value is getting decreased. The value is getting decreased. So next time you will get like 10000. And its decimal value is 16. Its decimal value, its equivalent decimal value is 16. So how we get 16? 0 into 2 power 0 is 0. 0 into 2 power 1 is 0. 0 into 2 power 3 is 0. 0 into 2 power 4, okay, is 0, like that. Right. So previously 1, 2, 3, 4, 5, right. So this is of course greater than n. So when you do again next time when you are doing the right shift, again what will happen? 1 and 3 zeros you will get. 1 and 3 zeros you will get. And which will be equivalent to, which will be equivalent to 8. And again when you do the 8, of course 8 is greater than n. The value of n is always 1. Always 1. Right, we are not changing the value of n here. And again next time when you are doing right shift, again what will happen? One more 0 will go to the next and you will get the value 100. So its equivalent decimal value is 4. Its equivalent decimal value is 4. So of course 4 is greater than n. So the process will be repeated. Right, again it will shift. Right, it will shift the binary value of the 4 to the right 1 time. So next you will get 10. The next you will get 1. So when you get 1, it will check the condition. So of course 1 is equal to 1. So again what will happen? It will move and you will get the output as 0. So now again it will come to this loop. And the value is 0 now, and it will check the condition whether 0 is greater than or equal to n. No, now it is not greater than or equal to n. So it's not possible to do any right shift. So what will happen? The loop will be terminated here and the value will be printed. Of course, we have the value 0. So your output will be 0. See, the Dth option is the right output for this particular pseudocode. So like this, you see every time we have to trace the output. So first, the main important thing is when you're tracing the output is you have to see the inputs, and then if there any loop comes, so how that loop will perform, right? So for loop means how it performs, then do while loop means how it performs, and then while loop means how it performs. Right, so all the conditions you need to check, and if the condition is satisfied means body of the loop will be executed. But do while alone is different. At least one time the statement will be executed and then it check the condition. If the condition is satisfied, then it repeatedly execute the statement that we have in do. Like that. And even operators also left shift, right shift, and right shift we have seen. Similarly, very different types of operators are there. So all these different types of operators, how it performs the operations, once we know that, it will be easy for us to trace the output. Okay, thank you.